Right, today in geometry we are looking at our last two sections, 10.5, 10.6, angle relationships and segment lengths in circles, along with our secants. So our very first theorem tells me that if a tangent and a chord or a secant intersect at a point of tangency on the circle, then the measure of each arc formed is 1/2 the measure of its intercepted arc. In the figure, line MJ is a secant line, and LK is a tangent line intersecting at the point of tangency J. Circle at point N. MJ is the intercepted arc, so MJ is my intersected arc. I have angle MJL of this angle, and arc MYJ, so this arc, is the intercepted arc of angle MJK of this one. So the measure of angle MJL is half the measure of the arc MJ. The measure of angle MJK is half the measure of arc MY. So this is exactly like what we were doing yesterday. So now we're going to look at intersecting lines in circles. If two lines intersect a circle, there are three places where those lines can intersect. First place, they can intersect on the circle, right here. The second place, they can intersect inside the circle. And finally, they can intersect outside the circle. So our angles inside the circle theorem. If two chords intersect inside a circle, the sum of the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So here, if I'm looking for measure of angle 1, that is going to equal half arc CD plus arc AB. If I'm looking for angle 2, it's the same thing, okay? So that's going to be half of arc BC, angle 2 here. Angle 2, if I'm looking for angle 2, that's going to be half the arc BC plus arc AD. Angles outside the circles theorem. So if a tangent and a secant, okay, two tangents or two secants intersect outside a circle, the measure of the angle formed is half the difference of the measures of the intercepted arcs. And again, it can look three different ways. Okay? So here's my tangent and my secant. This angle is equal to half this arc minus this arc. You could look where I have two tangents. This angle in here is still half that arc minus this arc. Or I could have two secants. Angle 3, right, that I'm looking for in here is still half this big arc minus this arc here. All right. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. So we have a segments of the chord theorem, which tells me if two chords intersect in the interior of a circle, the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So here I have these two chords that are intersecting. So if I take AE times EB, that's going to equal CE times ED. Tangents and secants. A secant segment is a segment that contains a chord of the circle and has exactly one endpoint outside the circle. The part of a secant segment that is outside the circle is called the external secant. So here's my secant. Q to R, that's the chord on the inside. P to Q then would be considered the external secant segment. And then S to P is our tangent segment. So then we have some theorems dealing with those. Segments of the secants theorem. If two secant segments share the same endpoint outside a circle, so right here, circle point E, the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external. So again, EA times EB, the whole thing, is equal to EC times ED. Segments of secants and tangents. If a secant and a tangent segment share an endpoint outside of a circle, the product of the lengths of the secant segment and its external segment equal the square of the length of the tangent. So here, EA quantity squared equals EC times ED. And I'm giving you formula sheets today that have all of these on here. So let's look at some examples. So this first one, it tells me line M is tangent to the circle. Find the measure of the red angle or arc. This should be our red right here. And on this one, it's this. So on part A, we're finding angle 1. So the measure of angle 1 is equal to, okay, this is just like what we were doing yesterday. It's half of that arc. Half of 130 is equal to 65 degrees. And so B, we're finding arc KJL. It's going to be 2 times that angle, 125, so 250 degrees. So down below it, 1, 2, and 3, find the indicated measure. Find the measure of angle 1. Again, I have the arc that goes with that. So the measure of angle 1 is half 210. So this is just nice review from yesterday, 105 degrees. Find arc, RST. I have the angle in there, so arc, RST, is equal to 2 times the angle of 98, so 196 degrees. And number 3, find arc, XY. So arc, XY, again, 2 times that angle 80, which is 160 degrees. So now if we come up over here on the right-hand side, this is new stuff for today. Find the value of X. Okay. This is my angle in here. Again, I have this arc out here and this arc over here. So X is equal to 1/2 my 2 arcs added together. 130 plus 156. So half of 286, which is 143 degrees. Number 2, again, I have 2 chords intersecting, so that angle is equal to half of those 2 arcs added together, 63 plus 89. So 63 plus 89 is 152, half of 152, 76 degrees. All right, on the back, more of these. So here they give me this angle 102, 102. So first I need to find this angle up here. I do that by 180 minus 102. And I get that 78. So I now know this is 78 degrees. So I know 78 is half of y plus 95. I can go ahead and get rid of my 1/2, multiply everything by 2. So then I have 156 equals y plus 95. So y is equal to 61 degrees. This next one, this angle in here is 30. I have 44 in A. So I know that 30 is equal to half A minus 44. Again, multiply everything by 2 to get rid of my 1/2. So I get 60 equals A minus 44. So add 44 to both sides. A is 104 degrees. Let's get this one right here now. So let's see. I am looking for angle 2 and then side 3. I want to find this angle. Notice I have this right triangle right here. And no, actually, sorry, that's this 2 is telling me that that part is 2. This is 3 as a radius, so that means this is also 3. So now again, if I look at this right triangle, I know that this side is 3, This is 5. So now if I want to find my angle X, I know that this side is 4 over here. So I'm looking for X. Okay? I need this angle right. If I go back to my triangle here, let me just erase this so that I can see. This is T, so S, this is T, S to T is 3. This is, I'm going to just label this P right now. This is P. I need this angle up here. So I can say that the sine of X is equal to 3/5. Use my inverse sine function. So this one is using lots of things that we've done before to find that that angle is 36.9 degrees. But that's only half of that. So now if I double that, that's going to get me this whole angle in here. So I get that that angle is 36.9 times 2. That gets me 73.8. Okay. So now I know that this angle is 73.8. So now 73.8 is equal to 1/2 X, which is what I'm finding, minus, so now I need this arc right here. That arc is going to be the same as this central angle. If I know that this angle was 36.9, I can do 90 minus 36.9 to find my other angle there, which was 53.1. And then double that to get 106.2. So minus 106.2. Multiply everything by 2. So then I have 147.6 equals X minus 106.2. So X is equal to 253.8. So this problem uses lots and lots of our previous stuff. SOHCAHTOA, inverse, sine, central angles, all of that fun stuff. Okay, let's come over here and look at this one now. I know X times X plus 4 equals X plus 2 times X plus 1. Distribute, I get X squared plus 4X. Over here I need to FOIL, so I get X squared plus X plus 2X plus 2. I get all of my X squareds on the same side. When I do that, they cancel. So now on this side, I really have 3X. So 4X minus 3X leaves me with X equals 2. So now they asked me to find ML, so I need to plug that in. So M to L. If I plug 2 in here, I get 4 and 3. So M to L is 7. J to K is 2 and 6 is 8. Okay. Look at the one below that. What is the value of X? So my formula says I take the outside one, 3, and I multiply it by the entire length. So the entire length of that is X plus 3. That's going to equal the outside one, 4, times the entire length, 4 plus 2 is 6. Distribute, so I get 3x plus 9 equals 24. Subtract 9, 3x equals 15, x equals 5. All right, so then this one over here, find RT and SU, same type of thing. So my chords multiply together, so x plus 1 times 3x equals x times 4x. So here I have 3x squared plus 3x equals 4x squared. Get all of my x squareds, get everything on the same sides. Then I end up with x squared minus 3x equals 0. I can factor an x out of that, and then I get x minus 3. Set those both equal to 0, so I get x minus 3 equals 0, x equals 0. So x equals 3 and x equals 0. If I'm finding a length, 0 is not going to be a possible answer. So now RT, let's see, this is 9 and 4, so that's 13. S to U, so this is 3 and 12, 15. So I'm just plugging those values back in. Okay, so this next one, find RS. And so I have my outside, so 16 squared equals x times x plus 8. So 16 squared is 256 equals x squared plus 8x. Everything on the same side. X squared plus 8x minus 256 equals 0. This one does not factor. It's not pretty. Okay, so we can do quadratic formula. So quadratic formula says x equals negative b, so negative 8, plus or minus the square root b squared, so 8 squared, minus 4 times 1 times negative 256, all divided by 2 times a, so 2 times 1. So I get negative 8 plus or minus the square root. Let's see, when I work all of that out, we have 64 plus 4 times 256, so the square root of 1088 divided by 2, so the square root of 1088, so I get negative 8 plus or minus 32.98 divided by 2. So I don't want the negative one because, again, I'm finding length, so I'm just going to do negative 8 plus 32.98 divided by 2, and I get x is 12.5, which is RS. Okay. Let's go down here. So find the values of x. So this very first one, I have a 9, a 6, an x, and a 5. So again, I have two secants that are outside the circle. So I take the outside part, 6 times the 2 multiplied to, or sorry, the 2 added together, so 6 plus 9. That's going to equal the outside 5 times x plus 5. So 9 plus 6 is 15. Right? So 6 times 15, I get 90 equals 5x plus 25. Subtract 25, so I get 5x equals 65, divided by 5, x equals 13. This one over here, same, so now I have two chords. I multiply my chords together. So the first chord is 3 and x equals 6 times 4. So 3x equals 24 gets me x equals 8. All right, so down here, again, the outside 3 times the outside plus the inside equals the outside x plus 1 times outside plus inside. So here I get 3 times 5 plus x equals x plus 1 times 2x. So 15 plus 3x equals 2x squared plus 2x. Get everything on the same side, so I have 2x squared minus x minus 15 equals 0. Let's see if this will factor. So remember factoring, okay? Do 2x squared times negative 15. That gets me negative 30x squared. I'm trying to get a negative 1x. So I'm looking for what can I multiply together to get negative 30x squared, but add together to get a negative 1x. So what can I multiply together to get negative 30 that I can get a 1 out of? That's a negative 6 and a positive 5. So I'm going to, here, I'll erase this so I can go back to beginning factoring. So I'm going to rewrite this but I'm going to rewrite including -1 as -6 and a +5. So 2x squared minus 6x plus 5x minus 15 equals 0. So now I can factor by grouping. The first two have a 2x in common, and I get x minus 3 left. These have a 5 in common, I get x minus 3. Remember, when I factor by grouping, I should always get the same thing in parentheses. I combine the first set. So I get 2x plus 5 and an x minus 3. I set both of these equal to 0. So 2x plus 5 equals 0. X minus 3 equals 0. So here I get 2x equals -5. X equals -5 halves. Here I get x equals 3. I'm looking for a length. So here my length cannot be negative, so x equals 3 is my only one that works. All right, so come over here. So again, I'm going to take my outside. 15 squared equals x times x plus 14. 15 squared, so I get 225 equals x squared plus 14x. Everything on the same side, x squared plus 14x minus 225 equals 0. Doesn't factor, so we would do quadratic formula again. So x equals -14 plus or minus the square root. 14 squared minus 4 times 1 times -225. Everything divided by 2 times 1. When we work that all out, again, we're not interested in the -1 because we're finding length. So we are going to get x is approximately 9.6. This one up here, 18x equals 9 times 16. So I get 18x equals 144. X equals 8. And our last one here, so 18 times 18 plus 22 equals x times x plus 29. So here I have 18 times 40 equals x squared plus 29x. Move everything over, so I get x squared plus 29x minus 720 equals 0. This one will factor. So x and x, remember I'm looking for what can I multiply together to get -720, but add to get 29. So that is going to be a positive 45 and a -16. So then when I set both of those equal, I get x equals -45 and x equals 16. I'm finding x a length. -45 doesn't work, so x equals 16 is my answer. All right, so we did some tough ones on there to review factoring and quadratic formula. That wraps up chapter 10. Tomorrow we'll look at the test review and then take our test the next